Hi, so in this video we are going to learn about a combination generated function, algorithm. So in this case, we think that we are going to do this on lexicographic order. Okay? So what this lexicographic order means that it will be in a sorted order. Okay? Basically, if you look at this section for number, then that will be like 1 to 3 and then 1 to 4 and then 1 to 5 and so on. Basically, if two number A and B, and if they are like in this way, then it's a lexicographic order. So for from 4 item we are going to take 2 items each time. In this case the lexicographic order is like we are just incrementing the last one at the beginning. So 1 2 and then 1 3 and then 1 4. Okay, so that means we are incrementing 12 13 14 and then we are incrementing this one, so 23 24 and 34. So in this lexicographic order. Okay, so if you look at this and if we are just doing manually, so we will go like this. Take the first item, take the next one, that's 1 2 and then 1 3 and then 1 4. And once everything is done, so look at this section first, that if we are taking 2 items from 4 items, so always the initial will be 1 and 2. So that means if it's 3 items, I mean from 5 items, if we are going to take 3 items at a time, that means it's going to be 1 2 3. So if it is taking 4 items at a time, then it will be like 1 2 3 4. So in general, we can say if we are going to take R item from N item, then initial will be always 1 2 3 ... R. So that's the first combination in the lexicographic order. So in this section, we are just saying the positional index, okay, of an array of list items. So that is 1 2 3 up to R. So that's the first combination. Now if you look at this code, then it's saying generate combination. So total item count, so it could be 4, it could be like 4, total item is 4, and item count in each combination, that would be 2, right? Or it could be 5 and 3. So in this section we are just saying, okay, find the total combination. That's, we have a NCR function. That's how we calculate the total combination. I'm not going to explain the details of this initial function. So we can calculate the total combination, and then we are declaring a variable with result having 1 to total combination of rows and 1 to total item in each combination count of columns. Okay, so basically what we are saying that if we take 4 items, from 4 items, if we take 2 items at a time, then there will be 6 combination in total. So we are taking an array of 6 by 2. Okay, that's this line, and then index as long row index is equals to 1. Now in this section, the first combination will be 1 to R, so that is 1 to item count in each combination. So we are just saying, okay, this is the row index, that's the first row index, and this is the column index, and that's the column index, right? Now in this section, look at this section that we are going to increment in the lexicographic order. That means we have to increment the last item first, right? So we take the first two, 1 2, then we are incrementing by 1, so that is 1 3, and then we are incrementing by 1, that is 1 4, right? So the next in combination we are going to generate by incrementing the last item first. But up to how much we need to increment the last item? So we can increment up to n. So in this case n is 4, it could be up to 4. If in this case n is 5, it could go up to 5, and after that we cannot increment anymore. So the last item, the maximum value can have is 5. And if you look at this carefully, then the previous one, that means the second last, can have the maximum value of n minus 1. So last item, the maximum it could get is n. The second last, it could get maximum of n minus 1, and that is because the last item need to be n, because it's in a lexicographic order, right? And like third last item, it could like third last, then it could go up to n minus 2. That means in this case, if we just pick a index, right, column index, let's say, so call index, in this case this column index is basically equals to r, right? So call index is equals to, in this case it's going to be r. In this case it's going to be r minus 1. In this case it's going to be r minus 2. So if we want to declare something that okay, how much maximum we could go, then in this section we can just say okay, this is going to be n minus r, and that's the last column index. And that is because we can just say n for this one, but for this one it will be n minus 1, right? So in that case this formula become n minus r, and for the column index we have like r minus 1, right? So plus r minus 1. So this r and this are cancelled, so we have n minus 1 at the end. So that's the formula, that n minus r plus column index. So that's the maximum one can get, right? So for the last item it could go up to n, for the second last it could go up to n minus 1. So we had to have something, some validation that do this, increment the last item, or increment this item until we haven't reached to this maximum value, right? So this is the maximum value that one item can get, right? So in case of n equals to 5 or equals to 3, the first item, the maximum it could get is 5 minus, that's r, that means 3, and in this case the first item, that means column index is 1. So maximum it could get 3. So you can see the last item is 3, right? So that is 5 minus 3 plus 1. So the maximum is 5 minus 3 plus 1. So we can say we are done when we have first column value of all of this combination. We can just say that we are done when the first item is this. That means n minus r plus 1. So we know the termination condition, that we are done generating combination when we reach n minus r plus 1, right? Or you can say when we are not n minus r plus 1, because we are doing in this in lexicographical order. So this is going to be reached only once we are done, right? So that's this condition, that do while when, so that means this first column index, and then this is the row index of all of this combination, and this is saying that more until we are this, look through this, okay, generate this until we reach this particular item. So that is total item, that's n minus r plus 1, okay? So that's for the first item, that's the formula. So that is the termination condition of this loop. We could do another way, we could have a different termination condition, that once this row index is less than total combination, we could do that as well. But I want to explain this one so you understand that when we have enough combination in this particular thing. Okay, so this is termination condition. So in this section we can say max n minus r plus 1, right? N minus r plus 1. And for other item, instead of 1 it will be 2, for the second one it will be 3, for the third one, right? So that is this one. So you can say, so Now, so that's the termination condition. Now look at this section again. So once we reach at the maximum, what we need to do, we need to go back in the previous column and increment the previous value by 1, right? So that is 2. Just increment the previous one was 1, so increment this by 1 more, that is 2. And once we increment this one, what do we need to do? The next item will be +1 on this one, right? So, and then do again, like, once we haven't reached this maximum, and once we reach the maximum, go back 1 column again, and then increment by 1, so with the previous one, right? So look at this example, it will be much more clear in this section. So this is the first combination, and then we start this looping that do this until we have n-r+1 in first column. Now in this section it's saying that, okay, while this one, look at this section again, then when we reach at the maximum one, we go back 1 column. So that what we are doing, that, okay, if we are at the maximum position for a specific column, then decrease this by 1 and go back in the previous column. Okay, so that's this column, then this part that go back in the previous column. So initially we start with last column and we are incrementing. So if you look at this section, we get 1 2 3, we start with this one and increment by 1. Okay, so if I just run it and I'll show you example. So let's look at this. So let's see, local window. Look at this, 1 2 3, right? And in this section we are saying that, okay, do this until we reach into this particular position. Now we are saying, we are just checking that if we are at the maximum position in the last column, because we started with this last column, right? Because we want to increment the last one first, and then the second last one, and then the first, third last one, in this way. So we started with the last column. We're checking if we are at the maximum capacity. No, it can go up to 5, that means n. So we are not at the maximum capacity, so just clone whatever we have in the previous column. So this section will just clone this, so that is 1 2 3. We have the same data as the previous one. Okay, and then we are just saying, okay, increment this row index, because this is another combination, and as you know, we have to increment this last one by 1, right? So that is this 4, it becomes 4. And then we are saying that, if we are working in any other column than the last one. So I'll explain this little later one. And then we get this combination. Again, we are checking if we are at the maximum capacity. No, we are not at the maximum capacity. So clone the previous result, 1 to 4, and increment it by 1. So 1 to 5, right? So now in this section we are at our maximum capacity. We cannot increase this third column value one more time, because it will be 6, but we only have 5 items, right? So that's when we have to go back on column, right? So that's when this condition satisfied that we are at the maximum capacity. So go back on column, that is column index equals column index minus 1. So now we are at column index, that is 2 instead of 3. So that's, and we are checking that if we are at the maximum capacity of this one or not. So we are not, because it could go maximum of 4, right? So now again clone this row, so we get 1 to 5 again, and now still this column index is at 2, because we have to increment this one, because we have generated all the combination for the last item, right? So we have to increment this one. So now let's just increment this one, because we are at the column index 2. We're just adding 1 with this last column. Look at this section, we're just incrementing 1 with this with this column index. So we get this 135. Now look at this section, that we get 135, whereas we have one more valid combination with 1, 3 and 4, right? So that's when this loops comes in. Okay, so that if we are working any other column than the last one, so in that case what we need to do, we have incremented the previous column. Instead of 2 it becomes 3. Now we have to make this next one incremented by 1 with the previous one, right? So that's where this loops comes in, that this will become 1, 3 and 4. And again we go back in this third column because we have to increment the third one again, because 1, 3, 4 we can have one more combination with 1, 3 and 5. So we're done. Back again in column, third column, right? So we are not at maximum capacity because third column can have maximum of 5. So this will not validate. So clone this again, 1, 3, 4, row index, increment the last one by 1, 3, 5. We are still at last column, so we don't need to do anything. Go back. We are at maximum capacity in column, in the last column. So what we need to do, we need to go back again on column. So go back, and we know that this can have maximum of 4, right? So we don't need to go back anymore. So clone this again, 1, 3, 5, and we know that we have to increment this 3 to 4. Now again, the column index is at this position. We have to increment the other ones by whatever we had in the previous column, right? So that is this one, and we are just saying that previous we has 4, just put in this the next column it will have 5. So that is this one. It's just saying that increment by 1. Okay, so that is column index plus 1. We're not incrementing in the present column index, we are incrementing in this with the previous column index, right? So we get this in the last column again. So we are at our maximum capacity in the last column index here again, right? So we need to go back one time, and then we are checking that, okay, if we are at our maximum capacity in the second column index, yes, that's true, because maximum this second column can have is 4, right, for this particular example. So we need to go back one more column again. We are checking again that if we are at maximum capacity in first column, so that's the column index 1. No, we are not at the maximum capacity because it could have maximum of 3. So what we need to do, so let me run again. Okay, so generate 134, 135, 145. Oh, let's switch. One to 5, 1, 3, 4, 1, 3, 5, 1, 4, 5. Okay, now let's look at this section again. Okay, we are at this position, so we are checking that if we are at maximum capacity. Yes, we are at maximum capacity at column 3. We are at maximum capacity at column 2 as well. So we are going back to the column 1, and we are not at the maximum capacity at column 1. So what we need to do, we're just cloning this row, so 1, 4, 5, and then we're just saying, okay, in our first column we have to increment by 1, right? And that's where this loop becomes more reasonable. So we make this 2, and we know that the next one should be 3 instead of 4 in the first combination. It should be 2, 3, and 4, and then 2, 3, and then 5 in the lexicographic order, right? So that's where this loops comes in. That we increment this by 2, 1. So the next one should be 3 instead of 4, and then the next one should be 4, and we are done because we have incremented all the columns, right? So now we just need to increment this one again. So that's one combination, right? And then we're checking again that if we are at a maximum capacity in first column. No, we are not. And then we're just saying okay. So just clone this and then increment the last one, right? And we incremented the last one, so we are at maximum capacity. So go back one column, and we are not at a maximum capacity in this column because it could be 4, right? So clone this again to 3, 4, and increment the second column by 1. So it becomes 2, 4, 5, right? And then the next one should be 5. We are done. Let's check this, and it's saying that okay, the third column is at maximum capacity. The second column is at also maximum capacity. The first column is not at maximum capacity because it could be 3. So we clone again. So 2, 4, 5, and then just increment the first item. That becomes 3. So the next one will be 4 and 5. So that's where this loop comes in, and then we are at our 3, 4, 5, and then this condition will validate because we have reached to the maximum value of the first item's index, right? So that's where this loop ends. So that's it. We get all the position in the lexicographic order. So these are just giving us the position, right? 1, 2, 3. So now how this helps is that let's say you have 5 items, okay? So you can say E, H, P, R, and let's say T, right? We get this position, so we can just find all of these indexes, right? Like now let's see. And column delimiter. So you can just say index, that is this, and row number is going to be always 1, column number is going to be this. So you get this 1. Oh, sorry. Need to fix this. So 10 by 10, right? 30, yep. So it'll be more visible if you click this. So as you can see, it's easy once you have all of this position to generate all the combination taking from all of this item list. So that's it for this video. If you like my video, please hit the subscribe button and press the bell icon for more videos. Thank you.